So I have shown you a simple half-adder code, like how we are basically writing it and all, right? And also we have written you shown you the recordings also, right? So this was the thing which we were getting. We were basically getting an error. It was not generating our bit file, right? Or your bitstream was not generated. Why because you're not basically generating or you're not basically writing your constraints. That was the reason for that, right? Now, so now what are we going to do is we need to have our connections. Let me show you what I am talking about. Let me first of all open the elaborated design. Let us wait for the elaborated design to complete. Yes, so this was the elaborated design that I was talking about. Now, what was happening is this A is not yet connected to any physical pin, and B is also not connected to any physical input output pin, and this carry and sum are also not connected to any physical input output pin. Okay. Now we need to first of all connect it to any physical input output pin, right? Now, what are we going to do is simply we need to check for the data sheet. Okay. So how to check the data sheet is you simply go to Google and you can type it Zybo Z7 schematics. Okay. So a schematics will you are going to basically search for the schematics. Yeah, this is the schematics of this Zybo Z7 board which I was talking about. This is from Digilet. Okay. Now these are the schematics which we are going to have. Okay. So they are basically 13 pages schematics. And now what are we going to do is we are going to refer this headings. Okay. So this page is all related to PMODs and MIOs. Okay. So about PMODs and MIOs we will discuss later. Okay. After completing this, right? Next, we are going to have something known as VGA and general IO. 1 minute. Give me a minute. I'm getting a call. Yes. What does MIO, that and all we will discuss. Okay. That is already included in this slide that we will discuss. Okay. Yeah. And what is MIO, what is EMIO, that and all we will discuss in the architecture when we are going to discuss about that, right? Yeah. So this is VGA and general IO. This is also not our purpose. Ethernet and SD card, this and all the circuit related to that particular thing, and audio. And this is also not, we are not going to use it. HDMI, we are not going to use it, and USB, OTG. So we need to find for this FPGA configuration, right? So we have something known as FPGA configuration. This is also not related to us. DDR and MIO banks, no. Yeah, this one, FPGA banks. Okay. So you need to go to FPGA banks. Okay. So this is what we need to search for, right? Yeah. So this bank, we need to search for something known as switch. Okay. So let me show you what I am talking about. Let me show you the Zinc Zybo board. So this is the board I was talking about. Now this board, I have something known as switches. Okay. Basically, I have four switches and four push buttons. Okay. So this is nothing but my input output pins or input output buffers, you can say. Okay. So this I am going to connect it with my A and B. Okay. So this inputs A and B will be either connected to this switches or it will be either connected to this buttons. Okay. This particular process of connecting your switches or buttons to your actual module inputs is known as the process of constraints. Okay, you're basically writing down the constraints. Okay, now if you carefully observe over here, there is something known as Y16, and it is not clear over here. I will show you the image also. K19 and P16 and K18. So these are the numbers which are associated with this particular buttons. And for the switches also, if you carefully observe, you have something known as G15, P15, W13, T16, right? So these are the numbers which are associated with this particular switches and the buttons. Okay. So you are going to write down those numbers or you need to remember those numbers. Now, if you don't have the actual hardware with you, you can either go to this website and you can check for these numbers, or what you can do is you can open the schematics which I have opened over here and go to the first page. Okay. In the first page, you need to search for the switches. Okay. Where are the switches? They are basically written with the letter SW. I need to search where is this SW which is present. Now, if you cannot find it out where is SW which is present, you can just simply search it SW. Okay. Yeah. So these are the four switches which are present over here. SW0, 1, 2, 3. Okay. Now, if you further search for SW0, okay, and go down. So if you can search it further, it is going to take you to the FPGA configuration bank page. Yes. So here this SW0 is present, and this is the page where it is showing the FPGA banks. Okay. So this is nothing but my SW0, and it is connected to a pin which is known as G15. Okay. So what I'm going to do by knowing this is I'm going to open something known as schematic. There is an option which is known as schematic, which is present inside your Vivado. In the RTL analysis, there is something known as schematic. Just click on the schematic. Okay, schematic has opened already. Now here there is an option which is known as 4 IO ports. Just click on that option. Okay, so something will open down here. So if you elaborate this, so it is asking you that it is showing you the name which is A and the direction is input. Okay. So to input, you are going to give either switch or a push button. Okay. And interface negative DFF pair, it is not necessary. And you need to provide the package pin over here. So the package pin here is what is the package pin we have seen? SW0 is nothing but G15. So I'm going to simply write down G15. If you select the wrong part number, it is not going to show the package pin. Okay. And see, it is automatically detected. It is corresponding to bank 35. So you can see here, it is corresponding to bank number 35. Okay. Bank number 35, G15. Are you able to follow me? What I'm speaking, is it clear? Yeah, I will share everything. First, let us concentrate on this. Yeah. Yes, yes, I will share all those PPTs, all those PPTs and PDFs which I'm speaking about. So, is this clear? The process of providing the actual pins, is it clear? Last few steps, can you go it over again? Okay. So, what I am basically trying to is first I am going to select which input should I connect to switch or a push button. Okay. So here in my diagram, I have two inputs. I need to connect it to either a switch or a push button so that they will act as an input of my FPGA. Now, here for my switches, there are some numbers T16, W13, P15 and something, right? And for my push buttons also, there are numbers. Okay. Either if you have the actual hardware with you, you can refer to these numbers, or else you can go to the schematics and you can just type SW0 or SW1. Okay. So that you are going to get this particular thing. Okay. Which is basically present in FPGA banks. Okay. Now in the FPGA banks SW0, it is corresponding to G15. So what you're going to do here in the Vivado, you just click on this 4 IO ports which is present in the schematics portion, and after pressing this you will get this list A, B, carry, sum. A is basically an input, and its package pin you need to enter over here. So it is going to detect the bank as 35. Okay. I think it is clear, right? Yeah. And others, is it clear? So whoever has asked, is it clear? Yes. Okay. And what about others? Are you following me? Is it clear? Okay. Now, for B, what are we going to do with the B is let me connect the B to SW1. Okay. So let me connect it to SW1. So SW1 is basically connected to the number P15 P. Okay. So I need to write it down over here. P15. Okay. Next, my output, sorry, my, okay, it is declared as carry as input. Let me, I think I have written something. Okay, it is out only. Yeah, I was confused with this. Yeah. So carry is nothing but your output. Now, you are going to provide your outputs to LEDs. Okay. So for checking our outputs, we are going to see something, right? We should get some output, right? So that is nothing but my LED. So what I'm going to do for LEDs, I'm going to type down LED over here. Let's see, we are going to get something. LED, yeah. I have four LEDs which are present. So in the diagram, in the board also, where are my LEDs? Yeah, these are my LEDs. One, two, three, four. This LEDs only you can have the control from your FPGA side. Okay. These switches and these push buttons are connected to your FPGA. Okay. This is a Zinc FPGA where we are going to have a processing system and a programming logic. We have discussed that on that and all things, right? So the switches and push buttons are directly connected not to the processor. These are connected to your FPGA. Okay, so that's why you can access them directly. And these LEDs are also directly connected to your FPGA. Okay. Now my output I'm going to take from this LEDs. So let's say if I'm going to take the output from this carry from this LED. Okay. Now what is the LED number? So the LED number I should check it out. Let's say what is my LED number? LED 0. Yeah, LED 0 is M14. So I'm going to enter over here M14. And what is my sum? Sum I'm going to connect it to LED 1, which is M15. M15. Yeah, that's it. Okay. Now, so this is how you're going to provide your package bits. Are they clear? Any doubts or any queries? Okay, that's great. Now what are we going to do is we are going to change this IO standard also. Why we are going to change is here, if you carefully observe, it is written as VCC 3V3, that is 3 voltage, 3.3 voltage. Okay. And here it is by default 1.8 voltage. We need to change it from LVCMOS 33, that is 3.3 voltage. Everything we need to change LVCMOS 33 LVC 33, or else you are going to get some runtime errors. You need to change this one. Okay. And after providing all this information, you just click Control plus S, so that it is going to create a file which is known as XDC file. Okay. Where it is going to save all the constraints. Okay. Now what is the file name? Let's say bit file example, bit underscore file underscore constraints is my file name, and press OK. So this will be saved now. So here it will be saved. So in the sources, in the constraints category, you can check over here bitfile constraints.xdc. So it is going to automatically write down everything, set property package pin, everything. It is going, the tool have written these things, right? Now, after writing this and all, and after assigning all your pins, you're just going to click on generate bitstream and press yes. So it is going to generate the bitstream, and let us wait for the generation of the bitstream. So till then, any doubts or any queries, please let me know in the chat box. Any other queries? Is it clear? The process is it clear? So meanwhile, I will show you how to connect your FPGA and all. So I'm going to have something known as this USB cable. I hope my video is also visible, right? So this is my USB cable which I'm going to have, and I'm going to have a simple board with me. Okay. So what I'm going to do is there is something known as this USB interface with me. Okay. So here I can basically connect this USB cable. Okay. And I can program my FPGA. Okay. So after my FPGA has programmed, so let me show you one LED which is present over here. Where is this? Okay. First of all, let me connect it. I will show you. Yeah. So I have turned on my FPGA. So I'm getting multiple lights and all. So the reason I will explain. So there will be some program which is already present in the processor. So the processor is actually turning all these lights. Okay. So these are where are my switches? Yeah. So these are my switches and these are my push buttons. And above the switches, you are going to have this four LEDs. And we haven't yet programmed my FPGA, right? So we need to program my FPGA. So let us wait for the Vivado to complete it. Yes, so Bitstream has completed. Let me show you what exactly we are getting. Let me share my screen. It is, I've just connected my laptop's USB interface to my FPGA's interface. That's it. So we can see over here, right? Bitstream has completed and bitstream usually completed. After this, you need to connect your FPGA hardware with your system, right? After connecting it to your system, you are going to click on Open Hardware Manager. Okay. After clicking Open Hardware Manager and click OK, so it will basically open the hardware manager. It is going to manage, and you need to click on this option which is known as Open Target, and press open connect with the target. Okay, so you what is your system or host is going to connect with your FPGA and press allow. It is going to ask you this for only first time, I think so. So it is basically connecting with your FPGA. So let's wait for that particular connection to happen. Yes, so it has successfully connected with your FPGA. Okay, your system has successfully connected with your FPGA. Now you need to program your FPGA using the bitstream. Okay, so there is one option which is known as program device. So click on program device. So the system has already detected automatically the bitstream file where it is present. Okay, so you don't need to check for where is that bit file which is present in which location, or okay, and you can just click program. Okay, yeah. So my FPGA has successfully programmed. Let me show you. Okay. Have you attended the previous session, or have you watched all the previous session? Okay. So after programming your FPGA, there is one green light over here, right? So sorry, I mean this one. So this particular green light is going to indicate that you have successfully programmed your FPGA, right? So if this is going to tell you you have successfully programmed your FPGA. Now, these are my input pins, and if I'm going, sorry, this is my switch. Yeah. So these are my input pins. If I'm providing A is equal to 1 and B is equal to 0, my sum is equal to 1. A is equal to 1 and B is equal to 1, sum is equal to 0 and carry is equal to 1. Similarly, A is equal to 0 and B is equal to 1. My sum is equal to 1 and carry is equal to 0. That is how we are going to verify whether our program is running correctly or not. If both are equal to 0, my outputs are equal to 0. And if both are equal to 1, my carry is equal to 1 and sum is equal to 0. Okay. So this is how you are going to verify your design using an FPGA. Okay. What does each LED signify? Like how we know if the LED programming is error or success? Yeah, that is what we have only selected, right? Let me share my screen. So I have only selected which LED is corresponding to sum and which LED is corresponding to carry. I need to remember that, or else we cannot judge, right? So here I have decided this LED corresponds to my sum and this LED corresponds to my carry. And while I was providing the constraints itself, let me open this schematics. While providing the constraints itself, I have mentioned carry belongs to M14, M14 belongs to this particular LED. Okay, where is this LED? This LED, and sum corresponds to this LED. So I need to note it down when I'm providing the constraints. Okay. Yeah. So this is how you're going to work with your FPGAs. You are going to program your FPGA and work with your FPGA. I hope the process is clear. And initially it will be little bit hard, or it is lengthy, but if you do it for frequently, then this is a easy process, very easy process actually speaking. Okay. Yeah. So any other queries or any other doubts of how you're going to program your FPGA and how you're going to work with it? Could you explain the steps to get bitstream? Yeah, I will explain. So there are only two inputs. How many input output connection we can have through the switches, and yeah, it depends upon the FPGA board you are working. So basically, the board which we are having is going to support only 8 inputs. That's it. If you are going to have more than eight inputs, then you cannot use this board, and only four outputs you can use. Four LEDs you can use. Okay, apart from the switches and buttons, if you want to connect any external devices, there is something known as PMOD. Okay, that we will discuss in our next sessions. So you have something known as PMOD interface, which you are going to use for connecting your external devices like your sensors or something, right? Yeah. So generating the bitstream, it's a simple process. Let me show you one more time. Any other queries, anyone? So you can see I've disconnected my FPGA, so it is showing hardware shutdown. Okay, let me close. So after writing your code, just click on this run synthesis, or you can click on this elaborated. Sorry, you can click on this run synthesis. And before going to bitstream, you are going to click on the schematics, and you need to provide this constraints by clicking on this 4 input IO pins. Okay, and you need to save these constraints. And after that, just click on this generate bitstream. That's it. Your bitstream will be generated. Okay. Any other queries? So that's about this particular session. If you have any queries or any other doubts you wanted to discuss with me, you can stay and discuss, or else you can leave the session. Okay. Thank you.